Hello everyone, this is Group 2, and now I'm going to talk about our Challenge 3, SVD for recommendation systems. And first block of our code is import dependencies. We use NumPy, pandas, surprise, and surprise.model selections in our project. And the next part is importing the data and merge it together. Firstly, we read two data sets, and it's called movie and rating from the two CSV files. And we combining them into one DF merged on the movie ID here, this row. And the merged data can be used for the building a movie recommendation system model using the ratings. By using the left join, we ensure that we keep all movie info, even those without ratings. The result of the combination is shown below, and this is, we can see the first 5 rows of our data. Okay, and the next part, we're creating the simple subset for analysis. Before applying to our SVD model, we extract a small subset of movies and rating from full dataset. Here, these 4 movies, and its ID is corresponding to these 4 IDs. We extract a small subset of movies and rating from the full dataset, pivot into a user movie matrix with ratings. This allows us to analyze this rating behavior on a sample that is computationally cheaper to explore. The result of the pivot table is shown below here. And then it's time for us to apply the SVD model. Hold on. Here. This is the table. And then, firstly, we loaded a simple data frame into a dataset object, specifying the 1 to 5 rating scale used here, rating scale from 1 to 5. And then we split this data into a training set and a test set, allocating 75% of data for training and 25% for testing. Here, train set and test set equals to our data, and the test size is the 0.25. Okay, and then it is time for us to create an SVD model here. Instantiated an SVD recommendation model and fit it on the training data. After training, we use the fitted model to make predictions on the test set here, and generating the predicted rating for each user item pair. Finally, we calculated the root mean square error here, and between the predicted and the actual testing rates, test ratings, and get the root mean square error is 0.9405 here, approximately like this. And the next step, we cross-validate our model, SVD model data, and our measures is RMSE and MAE here. And we turn on the variables, and it printed this data for us. Next, we use grid search CV to find the optimal values for hyperparameters. Grid search. Then, after we find our optimal values, we use the optimal values to generate our final SVD model. And then after generating, we build full transit. After we got this SVD module, and we can apply it. And this for the testing, we can apply it into our test df here, test v2.csv. And we iterate every single test data. And UID is the user ID, IID is the movie ID. The prediction, we use this SVD module we just generated to predict the result, and we append it to the predicted ratings in this array. Finally, we drop the movie ID on the test data, and the example submission here is the example. Yep. And finally, we can save our test data into the ans.csv. And this is our report. Thank you for your listening.